Okay, I want to graph this function here, y equals 2x squared minus 8 divided by 4x plus 1. The first piece of information I need is the end behavior. Since the degree of the numerator is bigger than the degree of the denominator, I know that I don't have a horizontal asymptote. So to figure out the end behavior, I need to divide 4x plus 1 into 2x squared minus 8 in order to rewrite it. Okay, to do this I ask, what times 4x is equal to 2x squared? And the answer to that is 1/2 x. Then I'll multiply 1/2 x by 4x plus 1 and put it down here. Then I'm going to subtract this bottom piece from this piece. So we have 2x squared minus 2x squared is 0, and 0x minus 1/2 x is minus 1/2 x. Now I ask, what times 4x is negative 1/2 x, and that's negative 1/8. So I'm going to put that here. So now I have negative 1/8 times 4x plus 1. I'm going to bring down the negative 8. And then I'm going to take this times 4x plus 1 and put it down here. And now I'm going to subtract the second one from the first. We get negative 1/2 x minus a minus 1/2 x is 0, and negative 8 minus a minus 1/8. So we have our remainder of negative 63 over 8. So to rewrite this, we have 1/2 x minus 1/8 plus this remainder over 4x plus 1. Okay, so we have this here. Now, when we're looking for end behavior, we're looking for what happens as x goes to infinity or x goes to negative infinity. In both of these cases, this term right here is very, very close to 0. So as far as the end behavior goes, it's this piece here that dictates it. So we have y equals 1/2 x minus 1/8 is the end behavior asymptote, and it's also called a slant asymptote. Okay, so once again, this piece here is insignificant on the ends as x goes to infinity and negative infinity, and this piece is what is the guide for the graph of our function. So we have the slant asymptote is y equals 1/2 x minus 1/8. Okay, the next three pieces of information we need are vertical asymptotes and x and y-intercepts. To get the vertical asymptotes, we look to see where the denominator is 0. So we see that this is 0 and x is negative 1/4. Since negative 1/4 doesn't make the numerator 0, we know that x equals negative 1/4, or I should say we know that this 4x plus 1 is not going to cancel. So we know that negative 1/4 is going to be a vertical asymptote. To get the x-intercepts, I'm going to go ahead and factor the numerator. It factors as 2 times x plus 2 times x minus 2. So that means the x-intercepts, or what makes the numerator 0, are negative 2 and positive 2. Finally, we need the y-intercept. That we get by substituting 0 in for x. So we have 0 minus 8, or negative 8, 0 plus 1, or 1. So the y-intercept is negative 8 divided by 1, or negative 8. Okay, now we're ready to graph the function. I'm going to start by plotting all these pieces of information. And first off, I will plot the slant asymptote. Okay, for the slant asymptote, we know that the y-intercept is negative 1/8. The x-intercept is what makes this 0. If x is equal to 1/4, then I have 1/2 times 1/4, which is 1/8. If I subtract 1/8, I get 0. So the x-intercept is 1/4. To get the slant asymptote, I'm just going to connect those 2 points on the line and form the whole line. Now I'll plot the vertical asymptote, and I'll plot the intercepts using blue so I can tell what point, because I don't want to confuse those 2 points, which are just on the slant asymptote and they're just nothing more than a guide. I don't want to think that they're points on the graph. So I'm going to plot the intercepts in blue. Okay, now I want to get from that y-intercept to the right-hand side of this vertical asymptote. Okay, so I know the two choices are to go down towards the vertical asymptote or to go up towards infinity on that side of the vertical asymptote. Okay, in order for us to go from this y-intercept up there, we'd have to cross the x-axis again. But I know that these are my only two x-intercepts. So I can't go from here up to there without creating another x-intercept that I know I can't have. So I know that I have to go from this y-intercept downwards toward the vertical asymptote. Okay, now I need to arrive at this x-intercept. So each of my intercepts were this factor x minus 2 from here. That was multiplicity 1. So I know that to get through this x-intercept, I cross the graph. I don't bounce. I have to cross it because the multiplicity of that 0 is 1. Then to finish it off, I'm going to just follow this slant asymptote. Okay, now I want the behavior on the other side of the vertical asymptote. Since we went down on this side, and this 4x plus 1 has a power of 1, I know that this vertical asymptote, if you will, has an odd multiplicity. So when it goes down, or since it goes down on this side, it has to go up on this side. Okay, again, the power of this is 1, so the corresponding vertical asymptote, the function will go down on one side and up on the other. Okay, almost done. This 0 is multiplicity 1, so I know the graph pierces. And then it has to follow the slant asymptote on this side. Okay, so this here is a very rough sketch of the graph of this function.